Greetings and felicitations once again, fellow modelers. Welcome to my humble part of the galaxy. Got a lot in store for you again. I'll tell you what, first I got to thank some people. I want to thank my buddy Steve, Simon, Jack, John, Scott, Mark, Lance, and so on. I mean, I want to thank all the new people that have subscribed to my little video channel. My subscriptions have doubled over the last month or two. Thank you. Thanks again to Kurt Kuhn for hosting that link showing the 50-inch refit. Thank you. Also, I've got to tell you, I'm late. I'm late getting this thing out because I'll tell you what, I have had the week from hell. Did you see that Voyager episode, Year of Hell? Everything that could possibly go wrong has went wrong this last week. I mean, really. That's why I'm so late. Between the weather and the high winds, the wife and I spent 3 days just cleaning up around here from all the snowstorms and mess. I was putting this video together and the software crashed. One of the circuits that I went to solder in this episode, I don't know, I guess it's the board. I looked at it and it looks like it's the board. I mean, I'm not saying I'm infallible. I mean, I could have made a mistake, but not 3 or 4 or 5 times. So I'm going to have to resolder another board, create a new board essentially from another kit. Now, I didn't get to a couple of things that I wanted to in here because there's just already so much video, it's not even funny. So I'm going to have to break that up and put that into part of the next video. But we will get more electronics. You'll get more electronics in this. The last video was all electronics. This is about half electronics and half work. So it all goes hand in hand. At any rate, let's get to it. I did say one thing in here that was abjectly wrong. I said later in the video that I hadn't constructed or built a circuit in 20 years. That's not quite true. I've constructed and built several circuits on breadboards. I just haven't soldered a complete circuit together in 20 years until I put together that circuit in the last movie, the Sound Alike circuit. Anyway, I want to thank Steve Neal again. Thank you, Steve. Thank you. Steve showed my work on his website. Again, he's had a hell of a time trying to get everything together for that original series wall mount communications unit. Between the post office and everything else, he finally got it together and got it up and bragged on me about it. Thank you, Steve. Anyway, let's get to the modeling. And thank you. Thank you for coming in and viewing my videos every week. Well, here we are outside, having a look at the base. Now, I've built the cabinet up, but this is the first time I've got good weather to show it off and do a light test on it. As you can see, the top of the base fits flush with the cabinet, and there's going to be plenty of room for light to get through. Right here in each one of these spots, we'll still have room to put LEDs right up underneath. So you'll never even know this frame is here. Now, I've got to take this back and have a hole laser cut through the center. He was unable to do that last time for some reason, but we're going to get it done one way or another. Then I've got to add some support framing right through the center. And then the back will slide right in, and the electrical cord and everything will come out through the back, and the switches will all be in the front. So now I'll take it inside and do a light test on it. Well, here we are in the house doing a light test on Lance's base. Now you see Light comes through everywhere I want it to come through. All I've got to do is finish molding and casting the hemispheres that go here, place the schematic in here, add the LEDs all around the perimeter, add my LEDs for the different RGB colors here, schematics for the roll, pitch, yaw, and as you can see, it's looking pretty tasty. Look at that, my. As soon as I get that center framed up, it'll be perfect. Now, I didn't use anything but a $5 LED light bulb connected through a switch to 120. See there? That's my handy dandy light tester. Woohoo! Easy peasy. Here's another little item that everybody that gets into molding and casting and prop making and model making should really have around the house, and that is a digital scale. We're going to get into that in probably a week or so. We're going to do some molding and casting and pour some resin for the 50-inch refit parts and for the 1/120 scale bridge BC deck. Now, the reason why you need something like this is because you've got to measure by weight on some of these different silicone and resins, not by volume. And it may seem like a simple thing, but it's really easy to get screwed up in the difference between weight and volume. Think that you're measuring by weight when you're measuring by volume, and you find you don't have enough catalyst, or you've got too much resin or too much silicone, because the density and specific gravity of the catalyst might be a lot thinner than the catalyst or than the specific gravity of the resin or silicone. The catalyst is the stuff that makes everything harden, whether it's Bondo, fiberglass, resin, silicone, polyester. The catalyst is the active ingredient. Anyway, we'll get into more of that in a week or two. Here's the 1/120 bridge and BC deck of the Refit Enterprise sitting on a piece of 80,000 styrene. The reason for the styrene is simple. Some of the areas on the lower portion of the bottom of the disc are getting threadbare from sanding and whatnot. So what I'm going to have to do is I'm going to have to make a base plate to proper specifications to put underneath this to smooth everything out so it makes a smooth, even transition and looks studio accurate. I've also got to cut out a template from the underneath for the scratch build that I'm going to be doing for the interior back here. Now, as you see all this red, this is what the entire ship looked like, or the entire project looked like when I first got it. And even with bolts and nuts and washers, things got a little cockeyed every once in a while from all the sanding, putting, priming, and painting. I've got one seam right here that I've got to go back and epoxy again. So I need a base plate for all of this, and then I need this section for the interior. So I'm going to scratch build a complete interior so that you can look through the windows and see everybody in the officer's lounge, etc. Anyway, that's where we're at on that. More of this in next movie or two. Here we have Scott's upper engineering hull and neck section along with the torpedo bay for his dreadnought. Now, since I was working with power tools on Lance's refit base, I decided to go ahead and drill out some holes for lighting for Scott's neck and engineering hull. Now, I started pilot holes, 3 pilot holes down here on the bottom coming up through the bottom into the neck because all of this is solid cast white resin. The forward part of the neck is as normal, but all this back here is all solid white clear cast resin. It's been opaqued and painted white, but I needed to get wires from underneath the engineering hull up in to the nacelle that will go on top, aka dreadnought. Now, you need one of these long extended bits. You can drill a pilot hole through the bottom and, like I did, through the top until they almost meet to help guide the longer bit. Then you use one of these longer extended drill bits. You can pick these up at any Home Depot at just about any size or length that you need. And this is what I'm using to run wires into the third nacelle. Anyway, there's that. Okay, here's our circuit from last week. Our little voice to light circuit, as you can see, still works perfectly. This is a programmable soundboard, which I'll be getting into a little bit later. This is a new circuit that I've put all the components in except for the IC chips and the 9-volt battery connection. As you can see, I put the sockets in first. Here are the IC chips and a little piece of anti-static foam to keep you from running a static discharge across it and frying it. This is an interesting little tool that you can use to desolder components. You see, it's got a little vacuum. You push the lever down, desolder your component while the solder's still hot. It sucks the solder up inside of it so that you can pull the component out and maybe replace it or clean it up, resolder it in case you've got a cold solder connection or a bad solder connection. Should always have one of these handy. A little handy dandy dual screwdriver for unscrewing these little parts and little screws like on the circuit boards or what have you to get back to another circuit board, say. This is a heat sink. This is used for, say, IC chips or other sensitive components that are sensitive to high heat. You put this on your tang or on your little tab sticking out of your IC chip or transistor, what have you, high up, so close to the case, so that you can still solder the component into place, but this takes most of the heat away from the actual component. This is for pulling IC chips. That's exactly what it's called, an IC chip puller. This grabs the chips on both ends so you can firmly pull it straight out of your socket. Now, here's what our circuit is. This is a spinning roulette wheel. You may be wondering why I'm showing you this and what this may or may not have to do with science fiction, Starship models, or Star Trek model lighting. Well, I'll get to that. Because this circuit, like many other circuits, can be used for more than one purpose. I think you're going to get a little information here that you might not didn't expect a little bit later. Alright, that's what we have for that. Now I want to show you something else that goes along with this soundboard. Okay, here's our soundboard again. Now this is a programmable soundboard with 4 different channels and up to 5 minutes of programmable sound that you can program into this. But don't exceed too much over 5 minutes, because I'll tell you what, you'll lose everything. I've done it. This is one of those talking all occasion cards, Christmas cards. You get them for whatever occasion. Now watch.
Hi there, this is a karaoke card. Press the button to begin your recording.
Now, guess what? I've stripped this back, and this is almost exactly the same type of thing right here. This is a programmable soundboard, but it only has one channel. As you can see here, there's the button.
Hi there, this is a karaoke card. Press the button to begin your recording.
You've got your battery container right here, which takes one little disc battery. You got your main board, This activates it.
Hi there. This is a karaoke card.
And here's your little 8 ohm piezoelectric speaker. Essentially the same components that you see right here, but again, with only one channel and a shorter period of time for you to program. The difference is this costs between $15 and $20 if you program it yourself. This costs $8, $10. In fact, the actual cost of this is was $7.99. So I'm going to show you how to hack this soundboard as I show you how to program this, or what the capabilities for this board are. As you can see, my little light to sound board still working. What I'm going to do is I'm going to program some Lost in Space tunes or Lost in Space sounds and voice recordings in here. I'm going to program some phaser sounds from Star Trek, and I'm going to program some Next Generation stuff all into one board, just to show the operation of this board and the flexibility of this board. Okay, as stated earlier, this is the roulette wheel, the spinning roulette wheel. Now I've put all the parts in it with the exception of the 2 IC chips, and I haven't soldered the battery to it, or the battery case to it. So I'm going to flip this over and I'm going to start soldering everything to the board. I'm going to start from the outside, snip off all these little tips, and work my way inside to get all this stuff out of my way. And then the last thing I'm going to do is I'm going to solder each one of these little connections for the integrated circuit socket that will hold the integrated circuits in place. Now, when that's done, I'm going to solder the battery connection and test the circuit. Okay, here we have a couple of things for the tester's UFO build-up, scratch build, kit bash that I've been doing, whatever you want to call it. I've just about got the leg ready for silicone so I can make up some copies. I've got to add one piece here that'll go up into the bottom of the UFO. And this is something that I ran across that I've been looking for some time. My wife actually dug this out of some of her stuff, and before she threw it away, I was like, I've got to have that, because I'm going to use this for the clear dome for the UFO. Cool. While working on electronics, I've also been working on my buddy's Refit. These are the little bitty squares that go on the nose section of the Refit. I guess they're bow thrusters of some sort. So I painted them yellow, gonna let them dry, because I'm getting ready to Aztec the whole forward bow section, or the nose section where the deflector dish array is. So I need to get these done and get them in place. What I'm gonna do is just exactly what I've done thus far. Paint them yellow, let them dry, put them in place, finish the Aztecing. When everything's said and done and it's all ready to light, I'm going to drill 2 tiny holes into each one straight through and outside the other part, which I'll show later, so that it gets light from the interior of the engineering hall. Okay. Now, here's our other little circuit, but I've got to tell you, I've had a couple of problems with this circuit, to be brutally honest. I didn't have any function at all at first, because I looked and checked and the little foil had lifted off of the circuit board for the ground. So I had to find another ground. So I found another ground. After I found the other ground, I tested it. Only about half of it was working. So I went back and double checked all of my solder connections, and everything looked real good. But everything but 3 of the LEDs would light. So I went back and triple checked everything, got down there with a big magnifying glass, and sure as shooting, more foil had lifted off of the bottom of the circuit board so that there was no good connection. So here's what we've got so far. Okay, now here's what we've got. Partial operation. Unfortunately, it seems to want to stop at one of the LEDs that doesn't want to light. So, I swear this has been a day. Wow. You ever had one of those days where everything you did went totally back-asswards? That was today. Oh, there we go. Now, see, I'm gonna get another board, and I'm gonna take a totally different approach, because either I did something wrong or this is just a bad board. Now, I've been soldering circuits for a while, but to be brutally honest, before the last circuit, I had not constructed or soldered a circuit in 20 years. I had been working on big time stuff, not little bitty stuff. So that's where we're at. I'm gonna fix this and get it working, and if I don't get it working, I'm gonna get another board. Anyway, my whole point being is that you can extrapolate this into any other kind of use, especially if it comes to special effects. Now, how this operates is it's basically a roulette wheel. It spins around in circles as the capacitor discharges. It slows its rotation until it finally stops at a random light. Okay? Now, if you don't have everything laid out in a circuit, if you put all of your lights in a matrix, you can make this look just like the lights on the bridge of the Enterprise. And if you go one step further, if you feed the input by a 555 timer set to a specific rate of speed, you can alternately refire this circuit multiple times by replacing the switch with the output of a 555 timer. Think about that. If I get to it, I will try to do just that to show you exactly what I mean. So what you'll have is a pseudo auto random flashing circuit. This could also be used as part of the forward nacelle special effects circuit by running your lights across at a different pattern and having the 555 timer constantly refire it as it's starting to wind down. So we'll get into that some more later. That's taking an existing circuit and using it for another purpose, or repurposing the circuit by adding or subtracting a couple of small features. Okay, here we are in the computer room. We're getting ready to show proof of concept on using this board to work in conjunction with, say, firing phasers. Now, if you were going to do that, you would isolate the pickup mic so that you couldn't hear so that the outside voices and other sounds wouldn't get picked up. And you would put a speaker very close to the input of the mic and run the wires to, say, red or blue LEDs, and have those inside your Starship so that when you press the sound button on the soundboard for the phaser sound, you would get a light instantaneously. Here we go. Nifty, huh? See how you can go a little bit beyond what the design purpose of something was? I'm sure that this board with a 9-volt power supply, permanent 9-volt power supply, or wired into an existing 9-volt circuit with this mic hooked up directly to a speaker, or the speaker output hooked directly into the input here, you would only hear this when you pressed a button to fire phasers on that circuit. Proof of concept, proof of circuit. Well, I suppose that's it for this movie. Make sure to stay tuned for the blooper reel at the end of the credits. And as always, take care and keep on trekking. I'm out of here. Here we have the retractable leg for the Tester's UFO kit bash / project kit. I'm trying to turn it into a Mars Attacks pseudo retro 50s sci-fi retro 50 sci-fi blah 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 blah. Shit. Retro 50 sci-fi look, and I've just about got it done. I've got to do some final shaping and sanding, a little puttying, and then this will be ready for the model. Shit, let me start over. Here we have the scratch-built retractable leg for the Tester's UFO kit, or the Pegasus kit. This is really kind of like a cross between the Mars Attacks UFO leg, a retro 50 sci-fi look, and the Pegasus Alpha Centauri UFO kits. So I'm trying to modify that big Tester's model to make it look like something a little more 50s and retro. Anyway, all I've got to do is add the pin part where I pin it into the ship, cut these tangs down. I used all this to hold it while I spray painted it. I've got a little putty work to do, little sanding and shaping. This thing's just about ready. Then I'm going to mold this and make 3 copies and finish the build on that UFO. So much for that.